So I'm working on the final battle sequence of Act VIII right now, and I needed to try to dip into this idea of a massive horde, all of them kind of moving around and trying to control the camera view and the rendering of this. And so I thought I'd actually go back to the beginning of this and show you guys how that's set up. Now obviously we're going to have a whole bunch of enemies, we're going to have them wandering around the terrain. It's going to look hopefully somewhat epic. Right now I'm using Cycles, which is their ray tracing engine, same as the iRay on DAS that you may be more familiar with. I'm going to switch this back to Eevee so we get a little bit more real time. Eevee is a polygonal renderer, the same way that say Unreal Engine or Unity is, and it's going to be a lot more fast. It's going to be real time unlike this thing, but it's not going to look quite as good. So when we're doing the final render, we're going to switch back to Cycles. But this is good for setting up camera views and stuff. And one of the things we're doing is we've got a depth of field to try to hide the fact that there's only like 7 enemies. Because, and then up here we're going to have the archdemon roaring at you. Now let's look at how this is done from scratch. So we're now in Blender. Blender is a general purpose modeling and animation package, unlike DAS, which is very much a posing package. Most people don't create new content in DAS, they use existing content and then modify it and shape it. So in Blender, the first thing we're going to need is a terrain, a landscape. Your landscape is essentially a noise pattern. It's a 2D noise pattern. You can kind of see, based on how tall this is, the noise was brighter. If it's lower, then the noise was darker. And you have a bunch of different types of noise generators. So this is a heteroterrain. We could use fractals. We could use general turbulence, which is going to give you kind of very flat. We can use distorted edge terrain. That's kind of nice. There's a bunch of presets in Blender, which may be the most useful way of doing it. Oh wow, maybe not that one. It's a cliff face. It looks kind of nice. Mesas. And then inside each of these guys here, the very first element is the random seed. This is where it starts generating from. You have the offset of the noise. Where in the noise are you? You can change the size of the noise to get more details or less details. Oops. And you can accidentally lose track of the generator, in which case you have to start again. I wanted maybe Gully's a little bit excessive. Or maybe not. Let's use this one. Yeah, this looks good. This is actually very similar to the zombie scene. And what we're going to do is we're going to have our enemies kind of using this area here. Right now we don't have any materials assigned, so let's fix that first of all. By default, out of the box, we've got a bunch of them. This looks nice. I'm done with this one. And it's going to be really small right now, so let's bump that up a little. So maybe 50 by 50 by 10. And we've lost our light, so let's bring that with us. There we have our light. Cool. I'm actually happy with that for what we need. Okay, next thing we need to do is we need to get hold of a character. Now I used some characters from Mixamo for this. In theory you can bring stuff from DAS into Mixamo and back, but for anything Generation 8, which is what we're using, that's not actually doable. So in this case we're using the Mixamo built-in characters. Let's see. Okay, he'll do. There we have him. Hello. This is a general purpose demon. And if we now run him, we can see that he's animating. But you can also see he's only got a certain number of keyframes. And that's going to be a problem because he gets to that point and then he freezes. So the very first thing we're going to do is we're going to nonlinear package. We bring up our... Stop moving. We bring up... Hey, she. Need a little bit more space here. We create this one here into a full track. And have a look at our properties on him. And what we're going to do is we're going to repeat it. This is an animation that's designed to blend. And now we have him animating in place. If this was a Veta style production, what you would do is each character would have multiple animations like this. And let's make this a precise number so he doesn't glitch on that. Each character would have multiple animations, and they would be programmed to react in the same way that AIs in a computer game would be. There's a couple of big problems with it. The big one is it's going to be hard to do. I don't know Blender that well. But this will do for now. We'll learn. Maybe we get better on that. Okay. Now, we have one dude. We can move him around. And I guess if we were feeling, I guess we could just copy-paste them X number of times. Let's see. That's not actually what I wanted. I wanted that guy. Okay, now we just need to repeat this 10 to 15,000 times and we will have an army. That's going to take a while. Okay, let's cheat. Now, most of the time when you deal with this, what you're going to do is you're going to think of the world as a particle system. Or as a particle system spawning on top of it. This is how you would place, for example, rocks. So if I go back here and I asked for brown rocks, maybe a little bit too large. Let's reduce the size and increase the randomness a little bit and reduce the number. So that's how it would use a particle system to scatter these rocks. And we're going to do something very similar. What we're going to do is we go over here, we go down to particle system, and we add a new particle system. And it's going to be here, because obviously the way to get our characters to look nice is to treat them as hair. Now, down in our that's not children, hair shape. There. So right now it's rendering as path. That's not going to be very good for us. So let's get an object. And we had our single guy. So we're going to ask him to replicate that. Whee! Now, the scale might be right. I don't know, it certainly isn't quite correct for this guy. But they're kind of wandering around randomly up the edges and stuff. That doesn't look very good. First of all, increase the size a little bit. Where were we? The very first thing we need to do is stop them from stepping upside down. So go to rotation, set it to be on the global z-axis, which is upwards, and that looks a little bit better. Now they're still quite scattered because we only got 1,000 enemies, and they're all over the place. Where really what we only want them to do was kind of be here along the bottom of this. So let's do that. What we need to do is we need to go down to the vertex groups, and what we're going to do is we're going to paint just the area that we want. The redder it is, the more enemies we're going to have in that area. And this is going to avoid them being kind of sitting on the edge like that. We go back into our particle system, and we're going to use the vertex groups, and density is going to be our group. Here. Yay. Okay, that looks somewhat okay actually. They're a little bit too contained. I'm going to add some more space, and because they're trying to stay even, drop down until it's not quite so even, and then our rotation, we want to face them towards us. Now, one problem we have is that all of these guys animate on exactly the same timeline, and they're of course also completely identical. Now what we could do is we can bring in multiple of these guys, change up when they're animating, how they're animating, and then have multiple particle systems, each one with a different scale and height. And if we go back to where we started, that's essentially what we're doing here. We've got 1, 2, 3, 4, 5, 6, 7, 8 particle groups with different vertex groups, so that some enemies are allowed to be in certain areas, others not. Some are scaled differently, some are animating at different time intervals. Now obviously there's only like 3 enemies here, or 3 enemy types. Just a simple result of limited time and limited resources. But it's enough chaos that, combined with some more cheating, like our field of view blurring, fast moving camera, that you don't notice some of the limitations, like they're not actually moving forward. There's only like 5 types, 3 types. So we're cheating quite outrageously. But that's okay. Hopefully that was useful, and I'll get back to rendering this and see how it works out. Thanks.